Hi students, welcome to my channel. In this video, we are going to discuss how to sort the elements using heap sort technique. Okay, so we have already discussed the operations performed on a binary heap. Generally, what are the operations performed here? One is insertion operation and another one is delete min or delete max. If you want to add another operation, that also you can add like find min or find max. Okay, so but here by using these two operations we can sort the elements. Okay, so how can we perform? Maximum here we will consider this delete min operation to sort the elements using heap sort technique. Okay, consider an example. For example, the list of elements are 10, 8, 16, 14, 3, 12. These are the elements. Then how to sort the elements? The first step is construct a complete binary tree. What is complete binary tree? Complete binary tree is a binary tree in which each level L consisting of 2 power L nodes. Already I mentioned in the previous videos what is complete binary tree with examples. Okay, so now for these elements we will represent a complete binary tree. So here first root node 10, 8, 16, 14, 3, 12. Okay, this is a complete binary. So each level by level we will insert. Now here I am mentioning the positions 1, 2, 3, 4, 5, 6. Okay, so now to sort the elements here we will consider or we will construct max heap. What is max heap? Max heap means parent is greater than its children. In such a way, we will construct this complete binary tree into a max heap. So, how to convert this complete binary tree into max heap is our second step. What is second step now? Second step is construction of maximum heap. Now, these are the elements present. So, in which position we have to check the max heap property. So now totally what is the value of n? So n equal to 6. That means n is nothing but array size you can consider or the total number of elements present, n equal to 6. So first we have to check n by 2 position subtree whether is it in the form of a max heap. Okay, n by 2 means 6 by 2 which is third position. So check whether this subtree is following max heap property. Parent is greater than its children. Yes, it is satisfying. So n by 2 position is completed. After n by 2 position, next we have to check n by 2 minus 1 position, 6 by 2 minus 1, second position subtree. So the entire subtree now we have to check whether it is following max heap or not. So here it is 8 and its children are 14 and 3. Is it satisfying max heap property? No. Why? Because parent is 8 and here one of the children is 14. Parent here it should be greater than its children. Here it is violating the rule. So what shall we do? Here it is. So here we will move 14 to its parent position. That means 10 is as it is and this right side there is no change. Here it is 16. Here it is 12. On left hand side, here you will get 14. And on left hand side whole will be created and here it is 3. As this hole doesn't have any children, place this 8 in this hole position. Now what we have done? First we have checked at nth position, then n by 2 position, then n by 2 minus 1 position, then we will check n by 2 minus 2th position. That means 6 by 2 minus 2, 3 minus 2, 1. 1 means here. That means entire tree we have to check whether it is in the form of max heap or not. Observe here. Here it is 10. Children here are 14 and 16. What is maximum heap? Parent is greater than its children. It is violating the rule, na? So that's why it is not in the form of max heap. Then what shall we do? Find out max child in between these two. This is a big child. Compare this big child and its parent. As a parent is less, we will move 16 to its parent position. So, see, observe, I am from this tree, I am representing here. So, 16 is moved to its parent position. That means you will get only change in right side. This left side is as it is. 16, 14, 8, 3, after 16, here actually hole is created and here it is 12. Then where will be 10? 10 will be stored in temp. Now hole here. Now what shall we do? Again compare this 10 and find out hole's max child. Max child only one child and this is the big child. Now compare this 12 and 10 as 12 is greater. So we will move 12 to its parent position. Now from this tree 16 is as it is. This left side tree is as it is. There is no change. Sixteen's right. Now here you will get a 12 and then here hole is created. As a hole doesn't have any children, then insert that temp in the hole position. If you observe here, hole is moving towards down direction, which is called as percolate down operation. Okay, now what we have done? So we have done construction of max heap. So first step is complete binary tree construction and second step is just we have constructed max heap. Now what we have to do? Now we have to do the operation delete max from the maximum heap. That means which one we have to delete? This one we have to delete. Okay, so delete here it is nothing but, so we will move this to the last position. We will interchange these two. We will interchange these two. That means from here we will get 10, 14, 12, 14's left 8. Right here it is 3. As you have swapped, then what will happen? Here actually you will get 16. That means if this is my array, totally how many elements are there? 6 elements. 1, 2, 3, 4, 5, 6. So now the largest element in the array is 16, which is coming to the last position. Observe the positions 3, 4, 5, 6. So now 16 you will get here. So 16 is automatically placed in the correct position. Then we will not consider this and we will reduce our array size to 5 only. So 16 is already placed. Okay. So now if you observe, so then no need to represent this one. So what I am doing is, now I am representing 10, 14, here it is 12, 8, 8 and 3. If you swap first element and last element, is it in the form of max heap? Is it in the form of max heap? If it is in the form of max heap, okay, no problem. But here, this is not in the form of max heap. So again, what shall we do? Find out a big child. Big child is 14. So move this 14 to its parent position and store 10 in temporary variable. Here it is 14. Here hole is created and there is no change on right hand side. This holes left is 8, holes right is 3. Now where should we place this? 10 is our question marker. For that purpose only we are finding maximum child. Now again find out maximum child from the children of the whole. So which one is a big child? Big child is 8. Then compare this big child and temp. What is our temp? Our temp is 10. Okay. So what shall we do now? We will move 8 to its parent position. Parent position is nothing but whole position. Here it is 12 and here whole is created and here it is 3. Okay, now here whole is created. As it doesn't have any children, place a temp 10. Yeah, see what happened here? Here it is 10, na? 10 and 8 are compared. As 10 is big, we will place 10 here itself. Sorry. So now, see here. I am removing all this. Now here whole, compare this big child and 10. 10 is big, no. So 10 is placed here itself. Then what is max heap? You will get 14, 10, 12, 8, 3. This is a max heap. Now what happened here? Now next largest element is coming to the first position. Then what shall we do? We have to perform delete max operation. Delete max operation, that means this one you have to delete. This you have to place in the last position of the array. And this last element you will get in this position. That means now the tree is, here it is 3, 10, 12, 8. This 3 already here we have placed, na? No need to represent that 3. Okay, is it clear? Hope you understand, students. Okay, so now again after swapping it is not a max heap. So what shall we do here now again? So construct a max heap. How to find out max heap? Find out big child. This is big child. Compare 12 and 3. As 3 is less, so we will move 12 to its parent position. So 12, 10, 8. Here you will get 3. Now this is max heap. So what shall we do now? Again swap first element and last element. Now already your array consisting of 14 and 16. Now you will get 12 here. And in the root position you will get 8. 8, 10, 3. Now after interchanging these two elements, this is not max heap. Then find out or construct a max heap. How to construct max heap? Find out big child. Big child is 10. Compare this 10 with its parent. So in max heap parent should be greater. Here it is violating the rule. So move 10 to its parent position. Here a hole is created. Here it is 3. And this hole doesn't have any children. Place 8 here. This is max heap na. Then what shall we do? We will interchange the first element and last element. Now here you will get 10. Now from here, so here it is 3, 8, 10 already in the correct position. That's why we are not representing. I didn't observe that point. Okay. Now after performing delete max, is it a max heap? No. What shall we do? Find out big child. 8 is big chain. Compare with its parent. So the property is failed. Then here it is 8 and here it is 3. Again perform delete max operation. So then swap these two. Then you will get 3 and 8 you will get here. Okay. So now only one element is there. That is 3. See the sorted order. So 3, 8, 10, 12, 14, 16 is the sorted order for the given elements. In this way, we can sort the elements using heap sort technique. Hope you understand, students. If you understand, you please share with your friends so that they can learn easily the heap sort technique. If you have any doubts, please send me a message in the comment box. If you like the video, please subscribe the channel to get the latest updates. Thank you, students. Have a great day. Bye.